It's powered on.
I'd like to introduce Erich Black from Black & Associates. A representative from Flir. Eric's been here before, and he's going to introduce us to some brand new, state-of-the-art, never before seen, particularly the way of a infrared moisture meter. So with that, Erich Black.
Hello, everybody. I'm just going to grab a few of my dates here. Okay.
Strange prayers up there. Those things shake off over here.
Where's my laptop? Mouse on.
Everything's set.
And I need my tripod.
That's theirs.
Just grab my tripod. Oh, it's on. I see it. I see it.
The weather that we had, obviously,
Okay. What's up? Okay. I'm going to go ahead and get started. My name is Erich Black with Black & Associates, and I've passed out some literature for you guys to look over all the different types of thermal cameras. Things that are available are anywhere in price range from about $400 to about $50,000. So what I'm going to try and do here today is explain to you the differences between the models of thermal imagers and what type of thermal imager is appropriate for your application. I've got a bunch of them with me here today. I've got a moisture meter that has a built-in thermal imager in it. I have a Flir One, which is a smartphone or a tablet interface that will turn your smartphone into a thermal imager. And then I also have a E8, which is a handheld thermal imager. And I have a T-Series Flir T420. But what I'm going to do is I'm going to go through the different imagers. I'm going to start at the low end, and as the presentation goes on, I'll work my way up into the higher end products so that you can see what kind of performance you can get from the different cameras and how much bang for your buck you're going to be looking at. And one of the things that we're going to talk about today is the thermal sensitivity, or on the spec sheets for the equipment, you'll see it listed as NETD, which stands for Noise Equivalent Temperature Difference. It's listed in Celsius, and the numbers are quite confusing on the data sheets from the manufacturer. So I'm going to try and put them into layman's terms so you can understand what the manufacturer is trying to tell you about the performance of the product. We're going to start off with the moisture meter. This moisture meter from Flir, it has a pinless and a pin interface so that you can either plug in the pins to the bottom of the moisture meter, and this is more of a destructive test where you would place the pins into the surface that you're trying to measure, and it will give you a reading. And then on the back of the instrument is a sensor pad, and I'm going to pass this around the room so you guys can see it. What I want you to do is just place this sensor pad on your hand, and you'll see the moisture numbers change on the screen. Just above that sensor pad is an 80 by 60 resolution thermal imager. And you'll see the display on the screen. It has a laser button on it, and if you push this laser button, I'll try and do this. I don't know if you can see it over the internet, but it will help you determine where you're actually aiming the device. The NETD that I just mentioned a second ago is the thermal sensitivity that this product has. If you can think about it as a thermal image is made up of different shades of grayscale or rainbow, and a typical palette is made up of 256 shades or levels of scale. And this one, again, it has 256 shades of scale. Higher performance thermal cameras have a lower NETD number. So in this case, lower is higher performance. So the lowest number you can get will give you the best thermal sensitivity. When you're inspecting a boat or a hull and you're looking for moisture in that material, you only have a couple degrees to work with. So the better the thermal sensitivity, the tighter the range the camera can show you while still displaying all the 256 shades of palette. If a camera has a higher NETD, then it needs more of a temperature span to show you the same type of resolution. So if you can tighten your temperature span down to just a couple of degrees while maintaining 256 shades of either grayscale or rainbow, that's going to give you a much better image. Okay? The NETD of this moisture meter is 150 millikelvin, which is 0.15 Celsius degrees. And we're going to do some math today. I'm going to pull up my calculator and show you how much span the different products need. But again, there is a pin attachment for this moisture meter, or you can use the sensor pad. But I'll pass this around the room so you guys can see it. It will save images to an onboard memory. I believe the battery life on this is 18 hours, and it will save 9,999 images to the onboard memory. These images are bitmap images. They can't be, you can't adjust the level and span or temperatures after the fact. It's basically just a digital picture is what it is. It does not take a visual image. It only takes a thermal image. And again, there's a laser button. There's a menu button, and you can scroll through the menu. You can set a moisture alarm. So if you know that you're looking for 60% moisture or 50% moisture, you can set that alarm to any number that you want from 0 to 100. And once it sees that moisture content, it'll give you an audible tone or an audible beep. The system is very easy to use. Again, it just has a camera button to save an image, a menu button with a 4-way directional navigation. This is a return button and a laser button, and that's it. So with this instrument, you're going to want to be as close as possible to the side of the boat. The further away you get, the bigger the pixels are going to get. Yes?
Eric, on that, if you moisture the boat, the moisture reading goes off. you can take a picture right then and there of that against the wall?
You would want to step back about 3 to 6 feet to take a thermal image of that section. And moisture, it has a different density and heat capacity than the materials of the boat will. It will change the way the boat is altering temperature. When a boat is heating and cooling from day to night, the moisture content or structural defects within the boat will change temperature at a different rate. Ideally, you need to get heat into the boat somehow to see this. If the boat that you're inspecting is facing the sun and the sun is injecting heat into the boat, wherever there's moisture, it will be lagging behind. And at the end of the day, when the boat is in a cooling cycle, the moisture will show a hotter or a higher temperature, because again, it's always going to be lagging behind the atmosphere because of the density differences that it creates. I'll pull up a thermal image on the screen so you can see exactly what we're looking at. This is an image that I shot a few years ago. Let me see if I can get it to open here. Here we go. And I'm looking at the area around the anchor locker around the bow of this boat. I'm only using sunlight to heat the boat in this for this image. This is a 320 by 240 resolution thermal image, and I'm seeing a temperature difference from about 100 degrees where there's moisture to about 106 degrees where there's normal fiberglass here in this case. This was these are some images that I shot for Blue Water on Kent Island. One of my fishing buddies works for Blue Water, and during the summer I work as a mate on an offshore fishing boat, and we do marlin trips and tuna trips all summer long. But I don't want to try and get off topic too much. If you get me started on fishing, I'm not going to stop talking about catching white marlin and fishing the tournaments. So when you're imaging the boat, you're looking for patterns and anomalies that just don't belong, okay? Thermal imaging does not see through any materials. It doesn't see through the walls of your buildings. It doesn't see through your clothing. It doesn't see through the floor or through the boat itself. It only measures surface temperatures. So when you're scanning with thermography products, you have to get heat into the boat somehow. And here, I'm just lucky that the section that I'm imaging is facing the sun. This image was taken during the afternoon, and the sun is injecting heat into the boat, and the moisture is resisting that temperature change. But even though you can see some of the structural materials like the stringers or some of the building materials of the boat, you're actually only seeing the surface temperatures in great detail. And there's an anomaly called thermal bridging or the heat capacity. You can see studs and walls, but you're not actually seeing through the wall. You're seeing a surface temperature difference created by the materials that are underneath the surface is what you're really seeing. So I've seen applications where people put heaters, space heaters, down into the hull of the boat to inject heat into the hull. I've seen videos on the internet where people take shrink wrap guns, heat guns, hair dryers, and just blow the side of the hull and get some heat into it. And wherever there's blistering or moisture in the hull of that boat, it's going to resist that temperature change, or it's going to change temperature at a different rate. And that's where your thermal imager is going to show you where to test. And then you can go over to that area and you can test it with your other tools, your moisture meters, your hammers, and you can verify the findings with additional tools. The more tools you use, the more accurately you're going to be able to diagnose and troubleshoot the problem. Yes.
That thing's giving you a percent of moisture. What's it based on? Is it an algorithm based on the temperature differential?
What it's doing is it's taking an electrical measurement across this surface, and as the moisture content changes beneath the surface, it will alter the way electricity is.
Yeah, so I mean, it's working like a standard moisture meter.
Yeah.
It's not using the thermal image.
Yeah, and the pins, the pins, what they do is it sends an electrical signal from one pin to the next, and as the moisture content changes between the pins, it's able to calculate a percentage.
Okay, I mean, it's working like our standard moisture meter. You know, it's not using the thermal image to calculate the
It is not using the thermal image to calculate the moisture. It is basically two tools in one. It's a moisture meter and it's a thermal sensor. But I'll pass this around the room. I'll start over.
How much does it cost?
This moisture meter costs $600 or $599. That is the MR160 from Flir. And there's actually a higher end model called the MR176, and that model will also measure relative humidity, dew point, atmospheric temperature. But I think that moisture meter is kind of better for you. You can always pull up the environmental conditions on the internet in the area or that you're inspecting, or use other ambient temperature and atmospheric humidity sensors. With that one, you're just going to get the thermal image and the moisture content.
What is the thermal image in that compared to a standalone as far as the quality?
That is an 80 by 60 resolution sensor. And if you multiply 80 pixels times 60 pixels, you get 4,800 temperature measurements in the thermal image. And this camera here is a 320 by 240 pixel image, which works out to be 76,800. So you go from 4,800 to 76,800, and there's also a huge price difference. This is a $10,000 thermal imager, and that one again is a $600 thermal imager. Yes.
How much is the 176?
The 176 is $1,000. It's $999. If you wanted to add the relative humidity and dew point sensor to the top of the instrument. And those moisture meters, if you open up your product literature, is on page 24 and 25 in the brochures. And you can see that there's a moisture meter with a sensor built into the top of it. But it has the exact same thermal image and exact same moisture probe built into it. Yes?
How's the quality on that compared to the one that ships on?
There are two versions of the Flir One. That's actually the next system that I was going to show you. There's the Flir One, which has the same sensor as the moisture meter, an 80 by 60 sensor. It has a little bit better millikelvin on it. This is a 100 millikelvin sensor. Okay, so the interval between the gaps or between the levels of span is 0.1 Celsius or 100 millikelvin. Again, it's an 80 by 60 sensor. This one also has a digital camera built into it. It has a 640 by 480 resolution digital sensor that's built into it. And it uses a technology that Flir is calling MSX. And what MSX does is it takes visual outlines and it looks for edges in the visual image and it lays them into the thermal image. But I'll pass this around the room. If you take it and point it down at the brochure, you'll see the letters on the thermal image. So what they're doing is they're trying to enhance the thermal image resolution by overlaying the visual lines and visual details from the digital camera into the thermal camera. The moisture meter does not have that technology. The Flir One starts at $200, and then there's a Pro version that is $400. And the Pro version is 4 times the pixel resolution of the original Flir One. The new Pro version has an extendable jack on it, so if you have your smartphone in a case, the extendable jack will interface with your phone while you have the case on it. Here I had to remove the case because it doesn't have the extendable jack. Now these devices are compatible with Apple phones and Android phones that use the USB type interface. So if you are ordering one of these, make sure you specify which type of phone you have, the Android phone or the Apple phone. And if you have the Android phone, there's USB and then there's USB-C. So you want to make sure that you specify if you have an Android-based phone that you're ordering the right port that interfaces with your, it plugs right into your recharge port on the bottom. And the Flir One Pro has a higher millikelvin rating. It has a 0.15 Celsius millikelvin rating. And the original Flir One has a 0.1. So again, lower numbers are going to give you more performance. Now, historically, infrared has been used for electrical applications where you're looking at 30, 40, 50 degrees of difference in temperature. When you have electrical hotspots, you've got things that are 200 degrees or more sometimes. When you're looking at the side of a hull, you might only have a couple of degrees to work with. So if you're trying to spot defects and flaws within that material, you really want to have the tightest temperature span or a camera that has a low millikelvin sensitivity. And I'll pass this around the room so that you can see it. You can record videos with this device. You can take snapshots with it. There's a free app from Flir called the Flir One that you can install on your smartphone or tablet, and it will allow you to record a movie or take pictures. And you can submit that movie or picture to your customer or with your inspection report. You can do this in a portrait or landscape format, and the camera will auto-rotate on the screen. And as you're taking your video, all you have to do is move around and record the temperatures. It will record temperatures on a cursor or crosshair, and it will show you a 1/10 of a degree temperature difference. So when you're scanning and recording, it will show that measurement on the screen itself. And again, I'll pass this around so you can see it. But you can do that in a portrait or a landscape format. And again, the Flir One, the standard version, is $200, and the Flir One Pro that has 4 times the pixel resolution is a $400 instrument. And again, you're looking at a millikelvin difference of 100 millikelvin on the standard Flir One and 150 millikelvin on the Flir One Pro. And again, that's a $200 and a $400 product from Flir. Yes.
So doesn't it seems kind of weird that the Pro would have a larger millikelvin difference?
Yes.
The first one, so.
It has a higher pixel resolution,
Right.
but it does not have the same thermal sensitivity. So they give you more pixels, but less sensitivity. I would almost prefer that you use the standard Flir One over the Pro, because pixel resolution in thermal imaging is only a factor of distance. I will get the exact same thermal image at 6 feet away with a lower resolution product that I get at 12 feet away with a higher resolution product. So you just have to get a little bit closer with the lower resolution. But it's the NETD that we're going to talk about today, or the thermal sensitivity, that is really going to be the performance mechanism that allows you to measure and see the structural defects and moisture intrusion and problems within the boat itself. So the next level up from that is this product here. This is called the EX series from Flir. It's available in 4 different models, and this is a demo camera from Flir, and I can set this up as an E4, an E5, an E6, or an E8. So if you do want to see the actual performance, I can actually program this camera, because it's a demonstration model from Flir, to show you the 4 different resolutions. I have this camera set right now to be an E6. The E6 is a $2,000 product from Flir, and this has a 0.06 Celsius sensitivity. And again, these numbers are on page 6 in your brochure. If you want to go to page 6, you'll see the EX series from Flir. This is the product that I'm going to recommend to you for your application, because it gives you a good thermal sensitivity with a decent resolution and will allow you to measure very, very small temperature differences. When you get up into the 30 millikelvin and 20 millikelvin products, you're talking $10,000 or more, okay? So you end up paying a lot more for a little bit more performance in sensitivity. So I feel that a 60 millikelvin sensor or a 0.06 Celsius is really where you want to be for measuring structural defects and seeing moisture intrusion into the boat itself. This thermal image here was taken with a 60 millikelvin sensor. Okay, this is a Micron 7800, that took this thermal image, and it has a 0.06 C sensitivity or 60 millikelvin NETD. And that is the same as this E6. This E6, though, is 160 by 120 in thermal resolution. That's how many pixels are on the screen. A 160 by 120 resolution is 19,200 individual temperature sensors. This camera will scan at 9 frames per second. And some of the higher end cameras will scan at 60 frames per second. But again, theirs are going to be a lot more expensive. These are used for targets that are moving and where you might get a smear in the image. If your target is stationary, then you can use the 9 hertz camera. The cameras from Flir are also restricted by the US government. If your camera scans at a frame rate greater than 9 frames per second, it cannot leave the United States because it's used by the military for targeting and tracking. Yeah, and shooting at people, yes. And even though the cameras are made overseas, once it touches US soil, it has to remain in the US if it scans with a frame rate greater than 9 frames per second. So for those of you that travel outside of the United States to scan, if you go to Canada, Mexico, or the Bahamas, you would need a product that scans at 9 frames per second or less. If TSA catches you with this camera in your checked luggage and you're headed to the Bahamas with it, they may confiscate it from you, and that would hurt to lose a $10,000 or $40,000 thermal imager confiscated by the TSA, and then you have to hire an attorney because there will be additional charges associated with that. So if you do plan on traveling internationally, this is the product that you're going to want to have, is the E6. It's a 9 hertz camera. It refreshes itself. The image refreshes itself 9 times every single second. And for the faster frame rate cameras, those have to remain inside the US. You can buy and sell it as long as you stay within the borders of the US, then the government doesn't consider you a terrorist. But if you put this camera in your checked baggage and try to go to China with it, now you're violating US customs. So this camera is also very easy to use. There's a shutter on the bottom, which is a lens protector. The camera has a 2-meter drop rating. You can drop it 2 meters to concrete. There's on the bottom of the LCD screen is a play button to recall saved images. You can get 500 images on this memory card. These are what are called radiometric images. You can take these images and load them into a free software from Flir, and you can adjust your level, span, temperature. You can put boxes and cursors for temperature measurements on the image. And it has a USB interface on the top of the camera that will allow you to download those pictures and use the free Flir Tools software. There's a pay-for version of Flir software called Tools Plus, and they will give you a 30-day free trial of that software so you can test drive it before you buy the product. One advantage of the Tools Plus program is you can do panoramic images. You could stand beside someone's boat, take 9 pictures of the side of their boat, and just drag and drop them onto the software, and it will Photoshop them into one larger image. And that software costs $300 from Flir. It's called Tools Plus. But if you want to test drive it before you buy it, you can. They will give you a 30-day free trial of that software program. But I find that most of our customers can do everything that they need to do using the free software from Flir. There's a menu button, just like on the moisture meter, and a 4-way directional arrow. You can change color palette. You can lock your temperature span. When you're scanning around somebody's boat, if you see the ground or asphalt, the camera might try and ramp up to 150 degrees or 140 degrees if it sees asphalt during the summertime. This product will allow you to lock that temperature span. So when you're scanning the side of someone's boat, you point the camera at a known goods section, lock that temperature range, and then when you continue scanning around their boat, you will see temperature differences with more detail. Because the camera right now will always adjust for level and span or temperature as it moves around the room. And then there's a trigger button to save your images. Again, this one will save an infrared and a digital picture, and you can load those into the software. The image format for this camera is a JPEG format, or a standard JPEG. It's really not a JPEG, though. It's more like JPEG Plus. It has a JPEG extension on it, but there's a lot of radiometric data embedded on top of that JPEG image. So when you load it into the software, you'll be able to make adjustments to it. It's not just a digital picture, but it does have a standard extension on it. So you can take that image and convert it to a bitmap, so you can give it to your customer, and then they won't have the ability to manipulate the data after the fact. The free software comes with a report writer that will give you a PDF report, and the pay-for software gives you a custom report writer that will allow you to do Microsoft Word reports, and will allow you flexibility to customize that report template. The PDF software is a little bit more restricted on how you can lay out your reports, but because the camera will save in a JPEG format, if you already have an existing software that you're using to submit images to customers, as long as it accepts a standard image, then you can dump that image right into that software and show it to your customers. But again, I have this camera set up right now to be an E6, which is a 160 by 120 thermal image, or 19,200 pixels with a 60 millikelvin sensor. But if you want to see the higher end version, the E8, I can actually reprogram the firmware on this product, and I can turn it into a 320, 240 system, which is $3,000. There are 4 versions of this model. There's the E4, the E5, the E6, and the E8, which are all on page 6 of your brochures. The E4 is a 80 by 60 resolution, and the sticker on that one is $950 for an E4. The E5 is a 120 by 90 resolution, and the sticker on that one is $1,200. The E6 is 160 by 120 pixels and is $2,000, and the E8 is $3,000 and is 320 by 240. So those are the 4 different versions of this product. You do not have to focus the thermal image with this camera. All you do is point and shoot with it. It's very simple to use. More expensive cameras require the operator to focus the product, and if you're not focused correctly, you'll get blurry images. So I'll pass this around the room again. Feel free to press the buttons, change the color palette on it. You can do whatever you want to it. I don't think there's any way that you could hurt the camera by playing in the menu. You can add temperature measurements, hot and cold cursor temperatures that will track the hottest spot or the coldest spot in the image. You can change the color palette from grayscale to rainbow. I've got it set up in a rainbow palette right now where red is hot and blue is cold. But if you have a military background and you want to work in the grayscale color palettes, you could certainly put the image into a grayscale format. And again, if you scan around this wall over here with the camera, you'll actually see the studs in the wall with the camera. But you're really not seeing through the wall again. You're just measuring the wall with so much detail that you can see where those studs are located. Just as if you looked at the side of a boat, you might be able to see where the building materials are, where the stringers are beneath the hull. But again, ideally, you want to try and get heat into the boat somehow. You want to either use a shrink wrap or heat gun, a hair dryer, the sun, or put a space heater down inside of the hull of the boat. So as the hull is heating, you'll see blistering defects, moisture defects. Again, here I was lucky enough that the side of the boat that I was imaging was facing the sun, and the energy is getting into the boat and is resisting where it's got moisture in it. But I'll pass this around the room so you can see it. Again, this is set up as an E6. But if you want to see one of the higher end versions, just let me know, and I will set the camera for that. The next level up from there is going to be the T series, and again, these are much more expensive cameras. We also do sell used cameras. I've got a used P40. I've got a P65 here. This is a P40 from Flir. This camera is about 10 years old. It is a 320 by 240 resolution camera. And one of the things that the infrared companies have done over the years is they've tried to make the products more and more affordable for people to use. Historically, they were only used by the military, and then they were used by utilities after that. And you'll see differences amongst the cameras. For instance, the amount of optics on the E6 is very, very small. It's about the size of a pencil. And the optics on this camera are several inches across. So the lens is made from a material called germanium. And to reduce the cost of the cameras, the manufacturer is reducing the amount of optics that come with the system. So this camera, again, is about 10 years old and stickered for about $20,000. And it's a used camera that we took in trade from the Smithsonian in Washington, D.C., and we're selling this product here for $4,500. And it saves images to a compact flash card. It has a video out and an S video out and an AC port on the back. This camera is a little bit harder to use because it requires a manual focus. There are plus/minus keys on the side of this camera that will manually focus the image. And I'll pass this around so you can see what a 320/240 system looks like. But all you have to do when I'm passing this around the room is use the plus/minus keys.
What's the sensitivity of that?
This one does not have an external screen now. It only has the viewfinder. The model above that one that has the external screen is this one here. This is the P65 from Flir. It has an external monitor on a pigtail that also mounts to the top of the camera. This one is a $53,000 thermal imager. The price has come down dramatically over the last 20 years on thermal imaging products. This camera is about 15 years old. It is also a 320/240 resolution. This one has features like Bluetooth. It has a built-in flash. It has a digital camera. It has an infrared camera and the LCD screen or remote control interface. Yes.
What is the sensitivity of that?
The sensitivity of the P40 is a 70 millikelvin, and the sensitivity of this one is a 50 millikelvin, or 0.05 Celsius. While we're on the topic, let me, what I'll do is, I want to cover the sensitivity and show you the differences in cameras. I'll pass this one around the room so you can see what this guy looks like. Again, just be careful with that one. That is a $53,000 thermal camera. So,
can it be dropped by 2 meters?
No, that one cannot be dropped by 2 meters, by the way. The E6 does have a drop rating, but the P series and T series from Flir should not be dropped. So again, when you're looking at the hull itself, this is a trim tab here that appears to be leaking into the stern, or around a fiberglass or hard top or a T-top. This is again the thermal pattern that you'll see as the moisture is resisting the changes in temperature. So again, here's my thermal image. I'm going to refocus this image. And what I'm going to do is change my color palette. Here we go. What I'm trying to do is show you different levels in the thermal image. And I've reduced the palette now from 256 shades of color to 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 colors. There are now only 9 colors that make up this thermal image. So you can see that the image is deteriorated because the camera is now only capable of showing nine different colors. Okay, and with those 9 different colors, the measurement made between these interval gaps is what we call the NETD, or thermal sensitivity of the product itself. If the camera is capable of displaying all 256 shades of color, then you'll get a much more, you'll have much more interval levels between the measurements. So I'm just going to pull up Microsoft Word and a calculator, and I'm going to show you mathematically the difference between a 60 millikelvin sensor and a 100 millikelvin sensor, or 0.1 Celsius. So the first one that we're going to do is a 100 millikelvin sensor. And I'm going to blow this up and make it real big so everybody can see it. A 0.1 Celsius degree NETD is equal to 0.1 times 256, and then you multiply that number times 1.8 to convert it to Fahrenheit. So 0.1 times 256 is 25.6 times 1.8. We'll convert this number to Fahrenheit for those of you that are in the US watching the program. And that gives you a span difference of 46 degrees. So what that means is that if your thermal camera has a sensitivity of 0.1 Celsius or a 100 millikelvin sensor in it, it needs to have a span difference of 46 degrees in order to show you 256 shades of color palette. So in this thermal image, let me go back to a standard palette here. In this thermal image, the temperature difference from the minimum to the maximum must be 46 degrees or greater for this camera to show you all the shades of color of grayscale or rainbow. So that's a 100 millikelvin sensor. So this was 46 Fahrenheit degrees of difference. A 0.06 Celsius degree NETD is 15.5 Celsius, or 27 degrees Fahrenheit. So the difference in a camera that has a thermal sensitivity of 0.06 versus a camera that has a 0.1 Celsius NETD, or thermal sensitivity, this camera needs 46 degrees from min to max to show you all the levels of color palette, when this camera only needs 27 degrees from min to max. And if you can show more shades of color with a smaller span, that's going to allow you to see the structural defects with more clarity and more detail. When you go with the lower end products that are 100 millikelvin or higher, you need more temperature difference to see the problem. So if you do have one of those cameras, the Flir One or one of the lower thermal sensitivity cameras, you have to get more heat into the boat to see the problem. I'm not saying it can't see the problem. I'm just saying you have to get more heat into the boat in order to find it. You've really got to get heat into the boat somehow, because if you're just using the atmosphere, the sun is only going to be on one side of the boat when you go out to do the inspection. There will always be a sunny side and a shady side, you know, while you're scanning and testing. So it is recommended that you do inject heat into the boat somehow, either using a shrink wrap or heat gun, a hair dryer, blow dryer, or put a space heater down into the hull of the boat. For, man, depending on the size of the boat, some of these boats can be, I imagine, pretty large. For you to inject enough heat into a hull using a space heater could take 24 hours. So you may want to get there a day ahead and put some type of heater down into the hull so that you can create a temperature difference so that the camera can actually find your problem. Okay, and then once you're locating a temperature difference, your knowledge about that boat will help you determine, am I seeing a normal thermal pattern? Is this just, you know, the structural stringers inside the hull, or am I seeing an anomaly created by blistering or moisture? So again, you can use shrink wrap or heat gun, or the or space heater if the hull is smaller. Again, if it's a huge boat, I mean, over 100 feet, you're probably going to want to use the heat gun and heat the boat from the outside, and just wave it like a wand over the boat and inject a couple degrees of temperature into the hull. You don't have to get it up to 200 degrees, but you just wave the heat gun in front of the hull so that you can get enough heat into it to find the defects. Yes.
One of the things I found very informative from your class, everything, was talking about the reflectiveness or the emissivity of the different colors. And that's something that we deal with on hulls all the time, and reflections from travel lifts, from surrounding things.
Mm-hmm.
And I found that very interesting. If you could explain a little bit of that.
Yes. What he's mentioning is the differences in emissivity of materials will affect the way the thermal imager displays a temperature. The cameras can lie to you. They can tell you something is hot when it's cold, and they can tell you something is cold when it's hot. And when a material like the fabric of the American flag is exposed to sunlight, it will absorb more and less heat depending on its color. So you're seeing a temperature difference by the absorption of infrared heat coming from sunlight. So the darker parts of this, I'm sorry, this color palette is inverted. I should have started with that. This is what we call a black hot color palette, where black is hot and white is cold in this image. So the darker sections will actually be warmer in this thermal image. So the white stripes are going to be the coolest, then the red stripes will be warmer, and then the blue around the stars will be the warmest in this image. Because darker colors are going to absorb more heat from the sunlight than lighter colors do. So if it's 105 degrees outside in the middle of the summer and you walk outside wearing head to toe black, you're not going to be very comfortable because you're absorbing so much heat from the sun. You're going to want to wear a lighter color so that you reflect more heat from the sun. And one of the things that I like to use is one of these Yeti cups. This is a stainless insulated cup, and when I first bought this cup, I thought I was just going to drink coffee out of it because I'm a coffee drinker. I like to drink coffee, but honestly, I put more ice water in this thing now than I do coffee. And this material utilizes the reflectiveness of the infrared spectrum to maintain temperature. It's a very low emissivity surface, and when heat from the sun or the atmosphere or the environment strikes this cup, it's reflected away from it, as opposed to being absorbed by it. Yeti makes a few different versions of this cup. They find that the customer wants colored cups or camouflage colored cups. Stick with the stainless cups. They will maintain temperature longer because of its manipulation of the emissivity in the infrared spectrum. It's a mirror in the infrared spectrum. It takes heat and bounces it right off. So when I look at this with my infrared camera here, so here is my cup on the screen, and what I'm going to do is I'm going to change color palettes here to rainbow. So red is hot and blue is cold. When I get my hand next to this cup, you'll see that my hand is red and it's emitting lots of heat. When I get my hand close to the cup, it looks like a mirror in the infrared spectrum because the heat is bouncing off of the material instead of being absorbed by it. If the material were absorbing the heat, then you would not see as much reflectivity or reflection in the cup. But because it has what we call a low emissivity surface, it's going to take that radiation and it's going to bounce it right back. And what you're seeing is radiation coming from my hand, bouncing off of the cup and coming back through the optics of the camera and displaying on the sensor. So it's not a perfect reflector, but it's an excellent reflector. If it were a perfect reflector, you would see the same color coming off the reflection that you see on the surface of my hand. So my hand is showing a red-white, and my reflection is showing an orange-yellow. So there is a little bit of absorption by the cup material. If you go with one of the finished cups that are painted like a powder blue or a light blue color, it's going to be a better absorber of heat. And if you put ice water in that, it's not going to maintain temperature the way the stainless cups do. The stainless products by Yeti and other manufacturers are excellent reflectors in the infrared spectrum. And this is one of the reasons why training is so important with thermal imaging. The cameras will lie to you, okay? It will tell you something is hot when it's really cold, and it might tell you something is cold when it's really hot. And you have to know what type of material that you're looking at to know that you're seeing a reflection or an emission. You might want to change your viewing angle a little bit to see if you're seeing a reflection. You might see a reflection of the sun off the side of a boat or the side of a hull. So here I have a hot plate, and I'm heating this. I'm going to do an auto scale here. And I have a vinyl decal of a marlin here on my hot plate. And then I have electrical tape and duct tape and aluminum as my three surfaces here. If I put a cursor on this image, and I'm going to blow this up for you. What I've done is I've put a crosshair on the electrical tape. And it's telling me that that crosshair is 255 degrees. So it's pretty hot, okay? What if I move that crosshair down to the duct tape, which is just below the electrical tape? The temperature jumps or drops from, what did I say, it was 255. It goes down to 243. And then when I look at the aluminum surface, now it's telling me that the aluminum surface is 92 degrees. I guarantee if you touch that thing, you're going to burn yourself. It only takes about 175 degrees to give you a blister burn. So my brother is wearing gloves to handle the hot plate. And the camera is lying to you. It's telling you that it's a temperature, but the infrared cameras and infrared products really don't measure temperature. They measure radiation. And what you're seeing is a difference in radiation. High emissivity materials radiate their temperatures very well back to the camera. Low emissivity materials like shiny or polished stainless materials reflect the atmosphere back to the camera. So I also have a frying pan here. And the frying pan is measuring a temperature of 302 degrees right now. And I'm going to do an auto span here. And what I want you to do is I want you to show me the surface. I need to look away from the hot plate a little bit. And I'm going to, again, use my cursor. Where's my cursor? I know I'm almost out of time. I've positioned my cursor again on the hot plate, and I'm getting a measurement of 302. Now spin it around and show me the back of it. On the back side, it did an auto scale, but it's only measuring 110 degrees on the back of it. Again, I guarantee you touch it, you'll burn yourself. But the camera is lying to you. So we do recommend that if you're taking thermal images for your customers, that you go to a level 1 training class. We offer level 1 training classes here locally to certify you. There are 3 levels of certification for infrared. Level 1 is all about understanding the infrared spectrum and infrared theory, and each course is $1,400. There are a couple different schools that offer thermal infrared training, and ours is called the Infrared Technical Institute, is the training organization for Black & Associates. You can see our information on the internet. If you go to tomwblack.com, you can see the location of our next training school. And we have one coming up the April 9th through the 12th. It's a 4-day program, and it's $1,395 per level. List price on that program is $2,000 per student, but we discount these products and programs so that you can get more affordable pricing. And those prices that I mentioned to you on the FLIR cameras, I will discount any of those prices 10% below list price. So the E6 again is a $2,000 model. That is the model that I'm recommending for you because it has a good price point with a high performance sensitivity at a 160/120 resolution. You could use the pay-for software and Photoshop the images using the $300 software and take high resolution images of the side of someone's boat just by dragging and dropping the photos onto what they call a panoramic assistant. And if I go into my library here, I'll see the panoramic. So this image here is actually two images of the side of someone's home. We shot this image first and then this image second and dropped it onto the panoramic assistant, and it photoshops those images into one picture. So you can use a 160/120 detector with a 60 millikelvin sensor, take a dozen pictures of the side of someone's boat, and then just drag and drop it onto the software, and it will Photoshop all those images into one larger picture for you. We're just about out of time. On my literature, again, is my email address and my website. If you guys have any questions about any of these products, do feel free to send us an email or look us up on the internet. Again, on the internet, it's tomwblack.com. Yes?
Are your courses geared for marine applications?
No, our courses do cover marine applications, but the level 1 certification is a broad spectrum course. It's designed to teach you how to use your camera, understand the infrared spectrum.
I have that. I'm looking for a course specifically geared for uses that I'm going to have. No one gives that, right?
Not in a level 1 certification.
No, just for knowledge about how to use infrared when you're doing both inspections.
We do not offer a specific course for just the marine inspection application.
If someone offered it, I, for one, would go, and I'm sure a lot of others would.
Eric, if I may, I took the course, I took the level 1 course. If nobody's been through it, it is just loaded with knowledge about how the camera functions, about the physics of it, the chemistry and the physics that are involved with this, and how to use the camera and to not get caught in traps like he just showed us. There's more information than you can absorb in the course. And if you plan on getting into this, I found it a wealth of knowledge. Good course.
Yeah, because you already understand the boats, applying thermal imaging to your knowledge of boats will be an even fit. And once you understand that the camera is not really showing you temperature, that it's showing you radiation, once you apply that knowledge to what you already know about inspecting boats, then you'll be a more powerful inspector. And the more tools that you use, again, to cross-diagnose your conditions or your problems, the easier it's going to be to say to the customer, this is delamination, this is moisture intrusion. And using hammers and moisture meters, or maybe even doing a destructive test. Again, we consider this to be non-destructive testing, or NDT. But to verify your findings, sometimes I've seen people take destructive tests and do a core sample, or actually physically cut into the hull to make sure, or to verify their findings again for their customer. But by taking the level 1 course, you'll understand the infrared spectrum, how to take images from your camera, and understand when the camera is actually lying to you.
Excuse me, Eric.
Yes.
I might have missed it. How long is that course?
The course is a 4-day course, or 32 hours long. There's an exam at the end of the course, and all students must pass the exam with a grade of 80% or above. It's a 100-question multiple choice exam, and the passing grade is 80 and above. The course material and content is compliant with ASNT, or the American Society of Non-Destructive Testing, and they have guidelines for the certification classes that the courses have to follow and have to meet. And the guidelines are SNT TC1A are the guidelines from ASNT. And ASNT is the American Society for Non-Destructive Testing. But the courses are $1,395 or $1,400 per level, and there are 3 levels of certification recognized by ASNT. Yes, there was another question?
The MR77, is that just a moisture meter alone?
Yes, it is.
How much is that?
There's an MR60.
In MR77.
Yeah, the MR60 is $375, which just gives you the moisture, and the MR77 will give you the moisture with the atmospheric temperatures. I've got that here. Give me 1 second here. Oh, we also sell drones now as well. So for anyone looking to do drone inspections,
Do they have infrared cameras on
that have infrared cameras on them, yes. These are the Flir drones, but the sticker on these is going to be between $10,000 and $27,000 for one of the drone inspections, and that way you could fly with the drone and see the MR. Hold on here, 1 second here. The MR77 is $700. Yes.
Where's the panoramic assistance software available?
It's available online. You can do a 30-day trial of it. If you already have a Flir camera, you can download the Flir Tools software. And when you click on the Panorama tab at the top of the Flir Tools software, I'm sorry, this is Tools Plus.
It's in there?
Yeah, it's already in the Tools Plus program. And if you don't have the Tools Plus, you can download a 30-day trial from it from Flir's website. And all you have to do is drag and drop these photos onto this section of the screen, and it will Photoshop them into one larger.
Proper edges.
It does, yeah. It finds common edges in the camera itself. So if I drag and drop these 3 pictures, I just created a panoramic image just that quickly from those 3 individual snapshots of this parking lot with a substation behind it. And then I can submit a large resolution image to my customer from a low resolution camera. And that software, again, is $300 from Flir. But you can do a 30-day trial of it to make sure it's right for you, if it's something that you want to test drive before you actually pay for it. And we can offer you discounts on that product as well, too. I can give you a 10% discount on
The
that.
software runs on your laptop too?
Yeah, it runs on your laptop. Yeah, I'm running it on my laptop right now.
1 license per organization or 1 license?
2 licenses per software copy. So for $300, you can put it on 2 computers. You can put it on your portable laptop, and you can put it on your home computer or office computer. Yes. Again, I know I'm out of time. I went a little bit over my time limit here, but if you have any questions, my email address, if you open up your product brochures, is on the inside cover. For those of you watching on the internet, my email is mrinfrared@aol.com. It's spelled out MISTERINFRARED. It's mrinfrared@aol.com. Our website is tomwblack.com. And you can contact us either through the website or through email. If you have any questions or concerns, just give us a call, and I'll make sure you get good support. And again, we will offer a 10% discount to all the members of IIMS for coming to the conference, and I'll discount 10% off any product that Flir sells. Okay. Thank you again for your time.
Cup of coffee and ready to go.
Yeah, I wasn't the winner of the Powerball, so I'm not going to be buying that.